So in this video I'm going to show you where the quotient rule comes from. So we're going to start with a function f of x, and we're going to find the derivative of this function f of x using first principles. So we're going to find the limit as f of x plus h, which is the y value when you substitute in x plus h, which will be this value. Take away f of x, which is the y value when you substitute in x, and all divided by h. And you can see that that's what I have done here. So now I need to manipulate this around and around and around until I come up with a quotient rule. So that's what I am going to do. So the first thing I'm going to do is I'm going to bring this h out the front so that I'm not working with fractions over fractions. I'm just going to bring the h out to the front. And then the second thing I'm going to do is I'm going to write both of these fractions with the same denominator. And so to do that, I multiply this fraction by v of x, which gives me this bit here. And I'm going to multiply this fraction by v of x plus h on the top and the bottom, and that gives me what I've got here. Next, I'm going to take out this denominator and replace it with the h. So I basically multiply the numerators together and the denominators together and then separate them out just slightly differently, only so that I end up with divide by h on the bottom, which is going to be useful later. So the next thing that I do to create a situation where I can take out a common factor is that from this step to this step here, I add and subtract v of x, u of x. So I'm going to add it in and take it out, and you can see that I've done that here. The reason that I do that, and I've got the minus here at the subtraction first and the addition second, is that I want to use this first bit here to take a common factor of v of x out. See, I've got v of x out as a common factor there. And then for this second lot here, I want to take u of x out as a common factor. And that allows me to then have, in here, you can see the formation of u, the derivative of u of x happening here. So this is like f of x plus h minus f of x over h, but for u. So this is going to be my derivative of u, and this is going to be my derivative of v. And you can see already that I've got u times dv dx and v times du dx. You can see also that I've got a plus here because this is not quite in the correct format. We've actually got this round the wrong way. So if I rewrite the numerator so that I have the minus at the front, I have v of x plus h at the front. So this is like f of x plus h minus f of x. You can see that I can then take out a common factor of -1, whoops, from both of those, sorry about that. I can take out a common factor of -1 from all of this, and now I've got my derivative formula. And so I can bring this -1 as a common factor out the front to make it minus u of x, which brings that minus in here for our quotient rule. So now I've got v of du dx minus u of dv dx, which is what we have on the top line of our quotient rule. So let's have a look at what I've still got sitting around at the front here. So I've simplified in these purple brackets here the two terms into being just on h. That allows me to have at the front here this 1 on v, almost like v squared. And you can see where this limit comes in. When I apply the limit here, this will become v squared. I'm getting ahead of myself, so let's just move further along. So what I'm going to do is I'm going to put this purple section, I'm going to put this purple bracket back on the top of this. I'm going to multiply together so you can see that this top bit here is just what's in that purple bracket there. And this is my denominator now on the bottom. And now I'm going to apply the limit here. So when I apply the limit to this, oops, come on, scroll up. When I apply the limit to this, I apply the limit to v of x, and as the limit as h approaches 0 for v of x is just v of x. I apply the limit to this bracket, which gives me the limit, and now I've got my derivative formula. So this bit here actually gives me the derivative of u. So I'm going to continue applying this limit here. So I've got minus u of x. Now the limit as u of x, for u of x as h approaches 0, get it out, is u of x. And then I apply the limit to this thing here, which gives me the limit of v of x, which is in fact the derivative of v of x. So this bit here becomes the derivative of v of x. And then finally I apply my limit to the denominator, and so I get the limit as h approaches 0 of v of x plus h times v of x. Now as h approaches 0, this thing here approaches v of x. So v of x plus h approaches v of x as h approaches 0. So what I've got here is v of x, when you evaluate it, times v of x. So that is just my, let's see what this colour goes like. This bit here is just v of x squared. And then if I write that whole thing using y instead of f of x, so if y is equal to f of x, then f dashed x is dy dx. And v of u dash becomes v du dx, minus u of v dash becomes minus u dv dx, all over v squared, which is our quotient rule from our formula sheet.